Welcome to Unit 7, Lesson 3, Approximations with Local Linearity. To understand this lesson, first we have to review the point-slope form of a line. Remember that we have the slope-intercept form is y equals mx plus b. The standard form of a line looks like ax plus by equals c. Well, there's another form of a line that we use commonly. That's the point-slope form. It looks like this. Y minus y1 equals m times x minus x1, where m is the slope and x1, y1 is a point on the line. And where does this come from? Well, you can get this from the slope formula. We know that the slope formula is m. One way to write it is m equals y2 minus y1 over x2 minus x1. Multiply both sides by x2 minus y1, and we get this one. We're just generalizing x2 and y2 to x and y. So for example, a straight line with a slope of 0.5 passes through the point 4, 3. Write an equation for this line. Slope-intercept form makes it easy for you to write an equation if you know the slope and a point. So equation is going to be y minus y1. So we'll just use our point-slope form. Y minus y1 equals m times x minus x1. Well, m is 0.5. I replace m with 0.5. x1 is 4. I replace x1 with 4. y1 is 3. I replace y1 with 3. That's our equation. Y minus 3 equals 0.5 times x minus 4. Okay. All right, let's go to our main lesson. Approximations with local linearity. What does that even mean? Well, approximation is just a fancy word for estimate. For example, if f of x is 3.9976, I can approximate, let's say that f of 3, let's say f of 5 is 3.9976. We can estimate f of 5 to be about, and this is the squiggly line means estimate, to be about 4. That's what approximations means. Linearity means straight line. So we have a straight line like this. That's linearity. Local means just the area right around it. So another way of thinking about local just means close to it. So for example, if we know f of 5 is about 4, and f prime of 5 is about 1, I can estimate f of 5.1. That's local because 5.1 is close to 5. I can estimate that. But I don't want to use that to estimate like 13 because that's far away. That's not local. Okay? So what are we going to do? Well, let's look at some examples. Example 1. The height of an object h of t, where h is in meters and t is in seconds, is given by the function h of t is equal to 0.5 t cubed minus 2t squared plus 2t plus 2. Write an equation tangent to the graph of h at t equals 0. Use this equation to estimate h prime of 0.1. Sorry, typo here. Use this equation to estimate h of 0.1. All right. So let's look at the graph of h of t is equal to 0.5 t cubed minus 2t squared plus 2t plus 2. I graphed it right here. So we see that at t equals 0, the graph is at 2. H of t is at 2. We want to estimate h at 0.1. We want to know what h is when it's 0.1. So we want something like very close to 0, but not exactly. 0.1. Like right around here, 0.1. In fact, according to this graph, according to decimals, it's 2.18. But we're going to estimate and get something close to it. Well, it's a curve, right? But we can draw a tangent line. The tangent line is a straight line that passes through our point like this. So here's an example of a tangent line. So our tangent line must look like this. The tangent line passes through our point and has the same slope. So for our graph, tangent line looks like this. Why? Because it passes through 0, 2, and it has a slope equal to the slope of our function at t equals 0. So this line is called the tangent line. So this is the tangent line. All right. Using this tangent line, we can estimate, this point. Using this tangent line, we can estimate this point, which is h of 0.1, because we can use the equation of this line. All right. So to figure out the equation of this line, we're going to use point slope form. We want our point and we want our slope. So we know that equation of a line in point slope form is, we're going to go back to our point slope form, y minus y1 equals m times x1 minus x minus x1. M is the slope, and then x1, y1 is our point. Well, we already have our point. We know that x1, y1 is 0, 2. How do we know 0, 2? Because we're using t equals 0. And we know that h of 0 is 2. How do we know? Well, we know that h of 0 is equal to 0.5 times 0 cubed minus 2 times 0 squared plus 2 times 0 plus 2, which is 2. That's why f of 0 is equal to 2. So our point is 0, 2. The slope, to figure out slope, we can use our derivative. The derivative of h of t, h prime of t is equal to 1.5 t squared minus 4t plus 2. That means that the derivative at 0 is going to equal to 1.5 times 0 squared minus 4 times 0 plus 2, which is still equal to 2. So our slope is 2. Why? Because h prime of 0 is equal to 2. Plug this into the equation and we get y minus 2 is equal to 2 times x minus 0. That's our equation. We can simplify if we want. We don't have to. If we simplify, that's y minus 2 equals 2x. Okay. Now that we have our equation, we can estimate h of 0.1. Because h of 0.1 means that we're estimating x to be 0.1. Plug this into the equation, and we get y minus 2 equals 2 times 0.1. This means that y minus 2 is equal to 0.2. Add 2 to both sides. and I get y equals 2.2. In other words, our estimate of x is 0.1 is going to be approximately 2.2. That is our approximate. Okay? Example 2. The temperature of a room over T is given by the function Ft. The temperature F is in degrees Fahrenheit, and the elapsed time T is in hours. This time we're not given the function itself, but we're told that f of 3 is 70, and f prime of 3 is 2.5. So write an equation for the line tangent to the graph of f of t at t equals 3. Use this information to approximate f of 3.2. Okay, so again, we use our point slope form. Y minus y1 is equal to m times x minus x1. This is even easier. Since f of 3 is 70, that means that our point is 370. And since f prime of 3 is 2.5, that means our slope is going to be 2.5. So I plug that in. y1 is 70. Slope is 2.5. x1 is 3. There's my equation. It's y minus 70 equals 2.5 times x minus 3. Now we want to approximate f of 3.2. So using this equation, y minus 70, I'm going to plug in 3.2 for x. This gets us y minus 70 is equal to 2.5 times 0.2. Okay, let's make this smaller so we have more room. Okay, so in other words, y minus 70 is equal to 2.5 times 0.2 is 0.5, because 0.2 is 1/5, and 1/5 is 2.5 is 0.5. This means that y equals 70.5. Of course, it's going to be pretty close to 70, because 3.2 is pretty close to 3. That means that f of 3.2 is approximately 70.5. We're using our linear approximation. Okay, that's it for this video.